Good morning, everyone. I know that some of you will watch this today. That was the day I filmed it, which is Thursday, and some of you will watch it much later than that. But if you don't mind sparing me a prayer or two, my back issues are definitely challenged right now. Okay, I would certainly appreciate your prayers. Okay, so Lewis structures. Lewis structures are a great idea and one of the big ideas of chemistry. It's probably our last big idea of chemistry that we're going to cover. We're going to have ideas, but you know how they're big ones like Q equals MC delta T and PV equals nRT and how to get from mass to moles that are really big ideas in chemistry, and Lewis structures is one of those because they're a way to represent covalent compounds. We did a lot with ionic compounds in the fall, but we put off covalent compounds and we're doing them now. So it is the dot and line representation of covalent compounds. Okay, and you know how usually you have two assignments due on the same day? Like you have notes, notes, two assignments. Well, we had notes, notes, and only one assignment because this is such an important idea to grasp. So please contact me if you're struggling to do the first Lewis structure assignment because we got to get off to a good start. So Lewis structures will be like, this is the Lewis structure representation of the hydrogen molecule H2. And this is the Lewis structure representation of the fluorine molecule F2. And we will get into on the next page how we come up with those. But it's the dots, each dot represents an electron, each line represents a pair of electrons, and it describes how the covalent compound is bonded together. A bond pair is a shared pair of electrons. So two electrons that both atoms share. So those electrons typically are found between the two atoms, and they'll be represented by a line. A pair of electrons is represented by a line. So if they were sharing two pairs of electrons, you'd see two lines. A lone pair is a pair of unshared electrons. These are electrons that will be found not between the two atoms, but around the outside of the, on the other side of the atom, and they're not shared. They really just belong to one atom or the other, but they also come in pairs, and so you'll see them written by these two pairs of dots, represented by a pair of dots. Like that. So that will be a lone pair, an unshared. So this hydrogen only has a bond pair and nothing else. Fluorine has a bond pair, and each fluorine has three lone pairs that belong solely to itself. Okay, so then in Lewis structures, we end up having three different kinds of bonds. I inadvertently omitted single bond. So single bond is one shared pair of electrons. One shared pair of electrons represented by a single line. One shared pair of electrons. A double bond, two shared pair of electrons. Pairs. Represented by two lines. And I bet you can guess where we're going with triple. A triple bond. A triple is three shared pairs of electrons, and that's it. That maxes out. There are no quadruple bonds, and it'll be represented by three parallel lines. The octet rule is a rule that has to do with the fact that noble gas notation, or not noble gas notation, but noble gas configuration, the electron configuration of a noble gas is extremely stable. And so atoms will take the form of, in a compound, they will want to be in a configuration that makes it they seem to have a noble gas notation. That's why so many molecules that were close to noble gas notation already were willing to lose an electron to get there, or gain an electron to get there. But what about if those guys in the middle who are like 4 electrons away from getting to a noble gas notation? Well, they're going to get it through the sharing of electrons, but they're going to do it while following the octet rule, which is the tendency of molecules and polyatomic ions to have structures in which 8 electrons surround each atom. The tendency of molecules and polyatomic ions to have structures in which 8 electrons surround each atom.